Hello everyone. In the last video, we discussed about how do you kickstart your data science career. And in continuation to that, this video I'd like to make to give a idea about different application areas in data science field. So let us go through different application, the major areas in data science. So first, let me give a larger picture. See, the larger picture is what your artificial intelligence. So I would say now every analytics based company, they would like to have a AI capabilities in their business. So the main idea of bringing AI capabilities to their business models is just to give a data driven solutions. And the key, of course, it is automations. They want to give some automation to their business process. So they would like to have a data driven. So basically, it's a data driven decision making. So where do we call it artificial intelligence? Any computer program or say algorithm, any algorithm which is going to act and mimic like human like decision making capability. Okay, we call such a computer program or algorithm having an artificial intelligence capability. In these algorithms, we have several set of algorithms. We call it as a machine learning algorithms. Machine learning algorithm. We have so many algorithms, right from simple linear regression model to the advanced neural network models. Everything comes under the machine learning algorithms. In fact, the people are entering into this field, you might get confused with the different jargons. Deep learning, again, deep learning is nothing but it's just any other machine learning algorithms. Of course, with little sophisticated characteristics like other machine learning model does not have. For example, a deep learning model can effectively handle image data set very effectively when compared to other machine learning algorithms because it has a special layer called convolution neural network layer. This layer takes care of handling the image kind of data. So these are some of the, now I can say it's a very sophisticated tool to solve a very complex problems. And not necessarily every business problem will be like a uh, linearly non-separable or a complex that could be solved only by deep learning models. There are several other business problems are there in which you can go with very classical models also. Here we are going to see what are the different major application areas when we talk about the ML algorithms. So though we call it as in general as ML algorithms, okay, we can categorize this into various subdivisions or specializations according to the nature of the data. So that is the main purpose of this session we are going to discuss. So first you should understand the broader picture. What is the broader picture? You should know what is AI, okay, and what is machine learning algorithms, and what is deep learning. So you should be clear with this. So AI is a very broader picture. Any applications you develop using machine learning algorithm, you generally called as a artificial intelligence capabilities. And deep learning algorithm is one among machine learning algorithms, which is nothing but our classical neural network model with an additional capabilities called convolution neural network layer. So this sophistication, what is this sophistication and all? When I list out the different application areas, I'll just give a brief about this. Okay, now we have a set of machine learning algorithms or AI models, whatever you call this. The very common aspect of ML algorithm or application area is number one, I would say it is a prediction model. If you are entering into the field of data science, obviously I would recommend you to start with, because the core of data science is what statistics. So definitely you need a very strong foundation in statistics to understand about what is the difference between a descriptive statistics and inferential statistics. So data data description, and we call this a descriptive statistics. So what is descriptive statistics? You're going to describe the data, how the data looks with the various graphs and structures. What does the data tells about? Whether the data, whatever you have collected is, what is the distribution of the data, whether the distribution is normal distribution or it's a skewed distribution. What what story really your data tells, that whatever the direct insight you're going to take from this data, that is called description, data set description. Number two, it's the inferential statistics. See, this inferential statistics forms the basis for the prediction model, form the basis for this prediction model. So in all the prediction model, we are going to predict y cap given, okay, y cap is a function of x. If I give x, the model should be able to predict y. For example, if I tell the body mass index of a person, my model should able to predict glucose. Glucose is the outcome variable. So not necessarily I should have only one independent variable. Your model can have a n number of p attributes. So I can have x1, x2, x1 univariate. When you have only one variable, we call it as a univariate prediction model. If you have multiple variables, like goes on up to p attributes, I can say it is a multivariate prediction model. So this multivariate, this prediction model, it came from the inferential statistics idea. So basically in descriptive statistics, you talk about the samples, what you have collected in your hand. Okay, we just talk about describe the samples, that's all. Whereas in inferential statistics, you just go one step and you're going to predict for the population data. Or in other way, I can say it like a future data set or production level data. So how your model is going to predict the outcome variable. So we call it as a prediction. So in this prediction model, we have two major categories. Okay, we have two major categories. Number one, whatever the variable I'm going to predict, look at in the case of glucose, generally the glucose is given in milligrams per deciliter or any other units, like a quantitative. Basically, glucose, the characteristic is quantitative. Like how do we measure, like 150 milligram per deciliter or 200 to 20? And the high diabetic people and all, they have a very high value, like very high sugar level. We call it as a 350, 380, 400 and all, right? So up to normal range, we call it as 100, around 180. Okay, then beyond 200 and all, we call it as like, different levels of diabetic. So the value of your measurement here, it is quantitative in nature, Y cap. When you're going to build a prediction model based on so many independent variables, okay, so how this data set, typically it looks like it is any tabular data set. Your data will be like looking like something like a spreadsheet data, and you have collected the information like so 1 2 3, I have n number of records. Let us say I have 1,000 records, and you have p attributes x1, x2, x2 and so on up to p attributes. Okay, you have p attributes. So in this, no, definitely you have one variable in which whatever the variable you are going to predict is the outcome variable. So I call that outcome variable as y variable. So y variable. So you are going to build a prediction model y as a function of various independent variables. These are the independent variables. Basically, what you should look here about the nature of the data is a numerical format n cross p, right? N is the number of records, p is the number of columns, attributes. Suppose you collect some data from some clinic, and that clinic they don't have the actual glucose measurement in Y. Instead of that, they say it is the record is either diabetic or healthy. So few records are diabetic and many records are healthy. And if you have this kind of pattern in your outcome variable or dependent variable, then we call this prediction model as a classification model. So typically, our prediction model is broadly classified into a regression model, or it is a classification model. If your outcome variable is quantitative value, we call it as a regression model. And if the outcome variable is a qualitative, just it is a, instead of measuring the exact glucose value, my model is going to say it is a diabetic or healthy. Such model we call it as a classification model. Classes need not be particularly binary. We can have a multi-class model also. Like instead of healthy and diabetic, I could say it's a healthy. It is a mild onset of diabetic. Okay, mild diabetic, and it is a very severe diabetic case. Right? No, I can have 3 labels. So such a model is called a multi-class classification model. So predominantly using a tabular data structures, any prediction models you build, and that model will be typically it could be either regression model or it is a classification model. So this is one application area in which you have to study. There are lots of algorithms pertaining to each cases according to the problem statement. So we generally we start with simple linear regression model. Then if the complexity of the model is non-linear, then you can go with other subcategory of regression model like simple linear regression. Then you can go with the quadratic regression. Then you can have a polynomial regression model, and so on. So we can have several algorithms under regression models. Similarly, in classification models also, we have a bunch of dozens of algorithms are there, starting with the simple logistic regression. So we can have logistic regression. Then we have k nearest neighbor algorithm, which is based predominantly it is based on distance based calculations. So I would say logistic regression, k nearest neighbor, algorithm. Then we have naives based class algorithm. Then we can have a classifier based on tree based classifiers like decision tree. We have random forest. These are all tree based classifiers. Then we have support vector machine. Then in that list, we have more sophisticated model, neural network, artificial neural network. And the extension of this ANN is what today we are talking in terms of deep learning model. Okay. So once you start learning about different algorithms, you'll come to know that over a period of time, you'll realize k nearest neighbor can be used as a regressor as well as a classifier. You'll appreciate why with a small tweak in the algorithm. So you can use this same algorithm to work as like a regressor as well as a classifier. Similarly, decision tree you can operate like a regressor as well as classifier. As for the random forest, also regressor as well as classifier. Support vector machine also we can use it as a regressor, as a classifier, and of course the neural network also regressor as well as a classifier. Whenever we predict a continuous quantitative variable, we call it as a regressor. Otherwise, categorical output means we use it as a classification model. Typically, logistic regression is strictly because we have a simple linear regression. The idea of logistic regression came from linear regression. And additionally, we are applying some logistic function towards to get a probability score of the class categories. So typically logistic regression is purely we use it as a classification model. Similarly, naive Bayes algorithm also, so very popularly we use it as a classifier only. So these are a bunch of algorithms you study under machine learning. This is one application area where it is a predominantly we use it as a prediction. Always you'll have a slight confusion between a prediction and forecast actually. Whereas the forecast is again, it is another application specialized area in which your data, nature of your data is different for forecast model. Forecast model. So maybe the English meaning of prediction and forecast looks same as a dictionary term, but in a statistical data science, as a data science terminology, they are different. The moment you talk about the forecast is always your data is attached with the time. So we generally we call it as a time series modeling. This application area we call it as a time series modeling. Any data which is attached with time. Maybe if I take a rainfall data, suppose you wanted to predict the rainfall, I should use the word forecast here, time series data. If I would like to forecast the rainfall during this coming monsoon, the monsoon this is going to start hit Kerala by second week, first or second week of June, and I would like to forecast the average rainfall Kerala or the nearby states is going to receive during that monsoon when it hits Kerala. I want to forecast based on last 10 years data. So if you have a last 10 years or even 5 years data, and so you can have the measurement like, so from day wise measurements or it's like a weekly measurement, or it could be or even a monthly measurement. So typically, let us say I just record, I have a last couple of years data starting from 2018, right? 2018, 1st June. Okay, this is my 2018 record. 2018, 1st June, how much millimeter of rainfall as an average day one received. Any particular region you can do the forecast, or to the overall Kerala also you can forecast. So 2nd June or 3rd June. So day wise you have a recording. No? So mostly your monsoon exists for a period of almost till July. It exists for a period of 60 to 70 days. And every year you have a record of, let us say, day wise recording like 60 to 70 records per year. And roughly you have a last 5 years record. So you can have a time series data. So in total, roughly around the 300 records. So basically, I can plot this signal like this data in the form of x-axis is the time. I can actually plot. So what is y-axis? It is a millimeter of rainfall, average millimeter of rainfall. Okay. So from 1st June till 31st of July, if you are measuring, if you are just plotting those records in time series, okay. So gradually the average rainfall increases and reach the peak during July, and gradually it's coming down and it's settled down, right? So this is the one pattern that you get it in the year 2013. Again, the 2014 data you're going to plot. So this data, again, it starts from 1st June and it goes on and reaches the peak. Probably the peak it receives, whatever the peak it reached during 2013 need not be same as 2014. So might be having a slightly higher peak value, and this is the gradual fall. And no, this is the kind of data as a time series data. So this kind of data you can attach for so many applications, right? What are the applications ranging from, this is an application of a meteorological applications. You forecast rainfall, or you can forecast any natural calamity, right? If you have a last 10-year record of earthquake, of a particular earthquake prone zone, and you can have a forecast model to predict the earthquake, when will be the next earthquake is likely to be, or tsunami, any kind of natural calamity. um, if you have a time based records, so with the, let us say you have this kind of records till up to the recent time, last 2019, okay, with the help of the previous records, and I'm going to predict, okay, I'm going to predict 2020 record, no, this comes under the model forecasting model. So here, this is the area I'm going to predict. So based on the past record of the variable, I'm going to predict what is the future. So here my y cap also the same variable like my x variable, right? But the past record of x, that is different actually. So unlike my prediction model, y is a function of x. Basically, this y and x are two different variables. But here, after all, I'm going to predict what is my prediction variable. My y cap is nothing but, okay, basically the same x variable in the future. So I could call it as a t plus 1 in future. Okay, I'm going to predict this t plus 1 as a function of, okay, earlier record, no, time instances. Yesterday record is t, day before yesterday is x of t minus 1, and so on. So that is a basic difference of forecast model. We work with time series data. Like we have a stock market trading data and all, it comes under time series. You can forecast the oil prices, and you can forecast gold price, and you can forecast stock trading prices. All those things comes under this no, forecast modeling. So this is another major application area you can think of when talk about algorithms, machine learning algorithm. Basically, here our data differs, right? Here there is no time stamping, but here you have a timestamp attached. It doesn't mean that your prediction model, you should not have a, among you have x1 to xp attribute. In that x1 to xp attribute, probably you could use one of the column could be a time column. Depend upon the context, I can use it. But however, as a broader perspective, still it is a prediction model. In that, maybe time could be the one of the independent variable which influence my y cap. Okay. So here my data is like a univariate model. So only one variable I'm using, that is a millimeter of rainfall I'm going to forecast, or the stock price I'm going to forecast, or the sales of a particular company. So last 5 years sales report, and I'm going to predict for the next quarter. You can forecast the next quarter sales figure, right? So predominantly here, the independent variable is a time, okay, in which the variable you're going to predict is a quantitative in nature. This kind of model is a forecast model. So there is another class of major application area. Some people are working very fond of working with image data. Like we have computer vision applications. So face recognition applications, right? Thumb recognition, biometric applications, right? These are the applications in which we use as image, forensic applications, security applications, surveillance applications. Even meteorological applications, people use satellite images and radar images, those application areas in which predominantly we use more number of images. If you are very, already if you have some quite number of experience working with image data, basically here my image is like a two-dimensional, again it's like a two-dimensional matrix. It is a spatial data actually. It is represented as f of x comma y. Unlike this tabular data, each column is one variable actually. Every column is one variable. Maybe one column is going to talk about age, another column is going to talk about the gender of the patient, Third column is going to talk about the weight of the person, and fourth column is the height, and so on. But when you talk about images, okay, image, it's like a matrix. So every value in the image is going to be as a pixel values, right? We call it as a pixel values. It's a gray level intensities. Suppose if I pick a value here, what is the at, okay, what is the f of maybe a third row and the last column, 3, 4, 5, 6, 7. At seventh column, I may have a gray level value something like 50. 50 is the gray level, and 3, comma 7 is the x and y coordinates, spatial coordinate. I have an intensity of the pixel is 50. So generally images, we have a gray level spans from 0 to 255. 0 means it's black, complete black pixel, and 255 is referred for complete white pixels. And range of values we have. So how do we treat such images? No. So traditionally, people, what they follow for images, in till the time we got a sophistication of deep learning algorithm with CNN architecture has emerged. Including myself, I worked with traditional feature engineering, feature extraction. You start with the feature extraction. Suppose I have two different patterns. Okay, so what we need to do now, we have to apply some feature engineering, feature extraction technique. So according to the domain, I need to, suppose if it is a medical image, I'm talking about brain images or some microscopic cell image kind of stuff. Predominantly, we extract some texture features. Texture features are all statistical representations. What is the mean value of the pixels? What is the standard deviation of the pixels? What is the entropy level? What is the smoothness level? Like we have a bunch of statistical measures you can measure from these pixel values. And you again, once again, you tabulate this in the form of this kind of data format, like tabular data format. So in each and every column, you are going to report the feature of, you can just take a record number 1, picture 1, and what is a feature 1 talking about? What is a feature 2? So what is a feature 3? And you are measuring, let us say, some 10 to 20 features, and you list out these features. And you can call it as like, you can label this feature, right? This is an image of a healthy person image. Okay, I can just label as a healthy. Similarly, the second picture, once again, you apply all the feature extraction, whatever the features you extracted, all 20 features, extract for a disease case. So these are the labels in which already the medical professional is already handled. Let us say already the medical professional has handled 500 records. So based on his experience-driven diagnosis he has done now, the medical profession, he start questioning about every patient, about the clinical history about the patient, and he start analyzing the image, and he come to the conclusion based on more or less like a qualitative conclusion he makes based on his experience, right? Maybe the same scan report, if you go and give to another second doctor, he might give a slightly different opinion because it is a qualitative opinions. But what we try to do in machine learning algorithm is we are going to have some quantitative decision, data driven decision making. So irrespective of, right, it's not going to give a qualitative decision making as like provided by the expert. After all, these labels are given only by the experts, right? How they traditionally they evaluate the cases, and how do they come to the conclusion. So once these images you convert it into form of a feature matrix, and once again you can make use of any of these algorithms whatever I have listed out, and you can use it as to predict for any new cases. Tomorrow any new patient step in, just we take a scan of for a particular problem, let us say we take a scan report and feed to the algorithm. What the algorithm will do, first it will extract all the features, and this particular feature set x1 to x20 is fed to the model, and model is going to say it is a healthy or it is a disease. Basically, we are trying to automate the process, not to replace the domain expert. Please remember, all the ML algorithms or AI model, remember, it is not going to replace the domain expert. It's not going to replace the meteorologist, or it's going to replace the medical professional. Basically, it's going to complement them in terms of If per day, let us say the doctor is handling 10 patients in a day, with the help of ML model, he could handle 50 to 100 patients. No, basically the efficiency of, we are basically increasing the efficiency of the decision making process, the quality of the decision making process, the speed of decision making process. In terms of accuracy also, we could say, because we are doing a quantitative decision making. So it's a automate, it's speed, and also it will improve the accuracy of the quality of the decision making process. It is just going to complement the domain expert. So domain expert already having a rich experience, no, domain experience. So your domain experience plus data driven model, when it join hands, no, we can have a very good decision making strategy for that particular problem. So this is how the actually image has been handled by ML algorithms traditionally, but thanks to deep learning algorithm in recent times, so it makes the feature extraction process completely obsolete. It's just thrown away this process. So what is the beauty of deep learning model is, we don't need to do a traditional manual feature engineering business, irrespective of the domain image, whether we are handling satellite image, or it is a medical image, or it is a radar images. So we have an architecture in neural deep learning model called convolution neural network layer. The CNN, the role of CNN layer is just to replace the manual feature engineering process. So I'm not going into deep into this, how what CNN layer is going to do and all. Probably in a separate video, when I'm talking about different algorithms. In future, I will talk about only about the CNN. I'll just give one explanation on this CNN part alone. But in a nutshell, in a broader perspective, try to understand what exactly the CNN layer is going to do with images is, like our manual feature engineering process, right? It is going to extract some feature from these images. So by applying uh, so different series of filters, like different dimensions defined by us, whether you want to apply 3x3 filter or a 5x5 filter or 7x5 filters, basically these filters are going to extract some features from the images based on the values. No, these are all the model parameters. Again, these filter 3x3 filter, which is in which CNN layer is going to operate. Initially, it's randomly, we initialize some with some random coefficients, and the model, as the model learns from the data, these coefficients automatically get adjusted with certain rules and principles defined by the algorithm. Predominantly, we use a multi-layer perceptron backpropagation algorithm. So each and every weights will be get adjusted according to that, and no, several iterations will take place to minimize the cost function. That is the logic behind how a CNN layer is basically extracting the features from the images. So we have a process called maxpo layer to downsample the size of the image and so on. Okay, so let us understand this. The sophistication of the deep learning model is to have additional the CNN layer architecture, and the CNN layer architecture is going to play a role of conventional feature extraction process in how we used to do it in previous years, those days. So because of this capability, and the beauty is irrespective of the domain. That is the beauty here. Suppose if you do the manual feature engineering business, if it is a medical image, we need to extract texture features. If it is like a outdoor images, some for example unmanned aerial vehicle or unmanned ground vehicle applications, autonomous car, these kind of applications, we work with the shape color features. Predominantly work with the shape and color features, okay, to recognize the different objects in the real world scenes. But in CNN, no, irrespective of your domain images, it can handle whatever the domain it accordingly. It will self learn the features. That is the beauty of this convolution neural network. So that is the success of the deep learning models in nowadays in lots of applications, particularly deal with images, face recognition applications. surveillance applications, and we can use it for non-destructive testing applications also. Some of people you are from many mechanical engineering and manufacturing, production, automotive engineering students are fascinately working in this data science, particularly in this non-destructive testing. Okay, so NDT images. So like our humans anatomy, we get this normal CT and MRI scan. For even for structures like concrete structures, I can get a scanning profile. I can have a, for oil piping, I can get a X-ray profile or even ultrasound profile. So different structures we can get represent those images. We can make use it for preventive maintenance applications. No, let us say in an industry there is a now very old pipe running in oil exploration company, and it is like a 20-30 years, and nobody knows, periodically we need to monitor the health of those pipes and all, right? So unless anything no serious no rupture of the pipes and it's a serious leakage damage that happens, no, before that we need to do a health monitoring. Those applications we call it as a non-destructive testing applications. Get a scanning profile, and your model is going to predict, okay, it's going to be like a faulty pipe or it's going to be the faulty structure. Imagine there is a 100-year-old bridge. You wanted to do a periodical health monitoring. Those are the areas in which image-based artificial intelligence model can predict, okay, whether it is going to be a faulty structure, faulty beam, and so the application areas enumerate, right? Irrespective of your field, this image processing is almost occupied in every other areas, right? So this is another sub specialization area, particularly if you're interested in image data, and you're so fascinated to apply machine learning algorithms to automate the process. And this is the area for you, deep learning. You need to learn what is the structure of deep learning architecture. And of course, generally I'd advise not to directly jump into the deep learning. Many aspirant no, the youngsters who wanted to learn enter into this field, they wanted to learn deep learning. Straight away they jump into the deep learning. If you look at the deep learning carefully, if you start working under the working into the mathematics of deep learning architecture, you will soon realize that there is a strong connection, um, the way in which the math and the cost function is defined. No, you will have a strong connection with the linear regression. You'll end up with the linear regression. So understanding your classical models, machine learning models, is first important, no, to venture into the deep learning. So I would recommend to learn all these algorithms, okay, and then you migrate to deep learning architecture. No, having the sound knowledge of regression will help you to appreciate the difference between the regression model. Of course, regression is a linear model when you're comparing the linear model, but deep learning is going to solve non-linear problems. So once you understand what is the drawback of a linear model, why linear model it is not capable to handle the linearly non-separable case, once you appreciate it, then only you can understand, okay, what special layer in deep learning architecture is going to handle such non-linearity, what is the meaning of hidden layers, what is the meaning of number of neurons in the hidden layer. All those things you can really appreciate once you have a classical understanding of these machine learning models. Straight away you jumping into this may not you appreciate the math and the stat behind the algorithm. So in general we call it as this is a parametric model, and deep learning model we call it as a non-parametric model. So this is another area. Okay, the another fourth application area I would once again, I just quickly summarize. One area is a prediction model. We have a bunch of algorithms, right? Prediction. And we understand prediction and forecasting, they are not same. They are different application areas. Forecast models, basically it's a time series analysis. And working with the images like computer vision application. computer vision application. You mean if you ask me only for image processing application, do we use the deep learning? My answer is no. Predominantly, it is the main, no, the inspiration came for the deep learning algorithm is basically to solve the images, no. That was the inspiration. So the people, the researchers started working on this convolution neural network and plus the classical backpropagation neural network model. So put together, they say it is a deep learning architecture. So it doesn't mean that it cannot solve other kind of problem. Yes, of course, you can use deep learning models to solve. In fact, even you can use it for the tabular data structure, like how this classical prediction model would solve. Even you can use the deep learning model for even for forecasting application also. Still, you can use for time series modeling, right? The very good application is nowadays in your mobile phones, right? Whenever you text certain words, right, your mobile is going to predict. Smartphones is going to predict for the sequence of other words, right? It's just one such application. No? Instead of forecasting the number, actually it's forecasting the words actually. So again, it is another subdomain, like another specialization, like text mining or NLP, text mining. So you again, there are a set of rules and you need to follow to handle the text data. How do I process the text data? How do I convert my text data into a numerical format? There are various methods are there. So you convert the text into a number format, and again, you can use this for any kind of applications like let us say, just for a quick example, like we give movie reviews and all, like any services like hotel, we give ratings and all, right? It's a good, it's average, and it's a poor, and movie and all, right? It's a good movie, average, and poor movie and all. You can have a prediction model based on the description about the reviews. So we can your model can predict whether it's a what category it belongs to. It's a good movie. You can have a label good movie. It's an average movie. It's or a bad movie. Like for a classification task. Also, you can make use of this text for sequence forecasting application also. So when you draft a text in your smartphone and it is going to give the next sequence of word, you just pick and drop, right? These applications comes under the forecasting, particularly for the text data. You do the forecast for the text data. So it forecasts the sequence of next sequence of words it just forecast. Again, we use the special models for forecasting modeling because it comes under the time series, or here it's a text sequence model. Here we use a different special model called recurrent neural network architecture. To be more precisely, it is called as a long short-term memory. So this is the algorithm running inside your sequence prediction in your when you just type a text, it gives the next few words, no forecast. So this kind of algorithms, again, in general, in a broader sense, again, it is a deep learning algorithm. But the algorithm, what you use it for, this image classification is slightly different from this recurrent neural in terms of architecture. It has a little feedback architecture and it is having a feed forward architecture. But actually the error is propagating back to adjust the model weights and all. But typically it uses a feed forward architecture, but recurrent neural network, it uses a feedback architecture. So the construction wise, your models are different. So you need to understand how the model learns. And like again, LSTM is a one type of recurrent neural network, and how LSTM models actually applied. You can apply for the text data. Also, you can apply for any numerical data like your the time series data, what I have told you. This apart from classical models, we can use deep learning model also. So what do you mean by classical models? Like we have a bunch of algorithm for predictions. For forecast model also, we have a classical models like simple decomposition algorithms. We can have a simple decomposition, starting from a simple decomposition algorithms to ARMA models, auto-regressive moving average model. We have auto-regressive integrated moving average model, and so on. These are the classical algorithms. Classical means 2-3 decades. These algorithms were there already. But today, the deep learning model also, like this RNN architecture also, people started using in forecasting application also. So finally, I would like to touch upon another major application area in your ML application is recommendation systems, recommendation engines. Also, we can call it as a recommendation systems. These recommendation systems are quite popular in your e-commerce industries who are using these recommendation systems, like Amazon, Flipkart, and these kind of e-commerce people. They recommend the things to us, right? The customer who purchased this product number 5 also purchased product number 8. This is a one such this is what this kind of association we call it as association models in recommendation. That's a part of an algorithm in recommendation system. We call it as a association rule mining, shortly called as the ARM. The customer who purchased bread packet also purchased milk. Even not only in the e-commerce, normal retail shop, no, what is our pattern of purchasing, right? Suppose in your basket, no, in your basket, in your cart, your shopping cart, what are the items you just pick from the rack? Which are the two items are coming almost come in common? Whenever you pick a bread packet, you're picking a jam bottle also. Bread and jam comes together. Like no, you try to associate one product to another product, no. So these kind of association, even in our online purchase also, it is. Suppose you purchase a book number 8, it started recommending another book also of similar content. So one thing is what recommending a product, similar product. Another thing is what it's trying to associate that product to another product. The two aspects are there. Even in your Netflix, Amazon Prime videos and all, when your movie watching pattern based on the, even in YouTube also, the based on the your movie watching pattern, since you have watched a content of adventure and action type of movie, adventure and action kind of movie, uh, for adventure and action, already you have watched adventure and action, and your model would recommend no, similar kind of, no, based on the content base it recommends, no. This is one such of an algorithm. We have various flavors are there in recommendation engines. So this is just recommending a similar product or similar services. This is association model is we call it as a market basket analysis, no. It try to associate one product to another product. It is going to give you, no, it when they are trying to give a association, no, it actually it's tempting the customer, right? Okay, let us, okay, we will purchase this product, along with this product we purchase this product also, and so on. So these kind of associations, is called as a market basket analysis. From the warehouse perspective, imagine that the warehouses of these items are arranged in very large area. So once we understand the way in which are the which are the items the customers purchase together, it will help us to organize our items in the warehouse also. So these are the various application areas of recommendations, personalized recommendations to the customers of which product the customer would like, which service the customer would like. These recommendation engines. Again, this is emerging as a separate application area. So these are the major application areas pertaining to artificial intelligence and machine learning perspective. So once again, I just give a quick overview. We have a prediction model, regression and classification models, and time series data. For that, we have a forecast models. And typically, as I told you, deep learning model is not only for the images, but I just put it as a separate specialization because you need to understand a different set of algorithms to deal with complex data. So to deal with the complex data, what kind of data comes under the complex, like completely unstructured data like images, videos, and even you can use the text data also for deep learning applications. These kind of data, again, you need to specialize on deep learning algorithms. We have a bunch of algorithms here also. And of course, those people are fascinated with the working with the text data. probably you can explore more on natural language processing. So here also Humpty number of applications are there. Machine translation is one of the very useful application nowadays, right? You land up in some foreign country, and you wanted to, if you speak in your own mother, in your own, either English to that foreign language conversion, or again foreign language to English conversion, or from your mother tongue to that foreign language conversions, all those things are possible with NLP. It's a part of NLP. Even when you open a particular certain website, you get chat boxes and all, no, chatbot. These chatbots automatically, it's a conversing with you. This is also part of NLP applications. So all these comes under no, text analytics, I would say. It's again, it's a specialized area. And finally, recommendation engines, no, recommendation systems. So one area, it's a part of, I would say, like, it's integrated with different application areas that I would consider as like unsupervised learning, because more predominantly our prediction model we call it as a supervised learning. Because why it's a supervised? Actually, we are predicting this y. This value is we already, the data, in the data we know what is this y. Whether it is a regression model, it is a glucose, or it is a diabetic or healthy. For that application, we use a classifier, right? There are certain data set. Predominantly, we work with data without having the outcome variable. Now, such models we call it as unsupervised learning. Predominantly, we do clustering for those things. So, clustering algorithms will be like a pre-processing technique. I don't want to specify as a special application area. Even if you wanted to build a certain prediction model in which you don't have the labels, what you can do is you can cluster the data. Once you cluster the data, you can attach the labels. Then you can treat it like your prediction classification models and so on. Even in your, when you work with recommendation systems, maybe you, all the columns you deal with only the independent variables. So what you try to do is what you try to associate one variable to another variable. So that's why we call it the association rule mining. You're just trying to associate one independent variable to another independent variable. So in association rule mining. So your clustering is a common technique which is imbibed in almost all the application. You should know at what instant I should use that algorithm. So it is integrated part now. So we have to use those techniques. So these are the areas of your ML application areas, machine learning, different algorithms to the different context. So to master each and every field, it will take its own time. So what I would recommend is, like, instead of you be a jack in all the trades, be a master in one trade, no, then you move on to the next. So each and everything, I know a little bit on this, I know a little bit on forecast, I know a little bit on deep learning, I know a little bit. Instead of going like this, be a master in one area, thoroughly first understand all the algorithms of prediction learning. Once you become confident, do a lot of problems in that, lot of projects, then you move on to the next area. Like, so instead of being a jack in all the trades, be a master in one trade and specialize yourself in one application area. So naturally, it is possible to specialize in all these areas over a period of time, right? So my recommendation is not no, don't touch all in one time. One by one, you just move on. That is the best way to master yourself in all these application areas. No. So in my last video, I was talking about the differences between data scientist versus big data architect. Okay, big data architect. Your profile, job profile is different. But in this session, what I was talking about, in the data scientist profile itself, you have various application areas. You need to expertise over a period of time, and whichever the area you are more fond of, you more work on that application area, and you just be master in that trade. So wish you all good luck in your career, data science career, whichever the area you take it forward. Okay, I'll meet you in some other presentations very shortly. Thank you for the listening.